registered participants. With that, I'd like to introduce you to today's moderator, Dr. Mark Weiss. Formerly of NIST, Mark is the founder and chair of the workshop on synchronization and timing systems, as well as a consultant for Spirent. Mark?
Hi, everybody. Thank you, Lauren, and welcome to the webinar, everyone. Could we have the next slide, please? I'm not seeing the slides advance. There we go. Great. So I want to say that this webinar is going to be presented in cooperation with a workshop on synchronization and timing systems. It's a workshop that's been going on annually for, I believe, 17 years. And the reason I'm mentioning that is because timing security is actually a very complex topic. Today's webinar will serve as a good introduction or perhaps an update for you to timing security. And attendees can see more in-depth information on this and many other topics at the upcoming workshop at WSTS, and what you see on the screen is the location time of that. And for a more complete agenda on WSTS, you can visit the link that's on the screen. Next slide, please. So a quick introduction to the webinar. Here's the outline. I'm concluding my introduction now. I'll be followed by Barry Dropping of Microsemi. He's a senior director of Microsemi, a 30-year veteran in the synchronization and timing field, formerly with Hewlett-Packard and Symmetricom. He's going to talk about the needs for timing in a few specific industries, mainly a few specific. There are many needs for timing, so he's going to focus on just a few important precision needs. And then Kevin Coggins of Booz Allen Hamilton, the vice president for PNT, previously director of Assured PNT for the U.S. Army. Kevin will talk about the reasons why you need to increase timing security, some of the threats and issues that can cause problems that some increased timing security and resilience can mitigate. Jim Platt from the Department of Homeland Security will give the last presentation focusing on options for mitigating timing issues and a larger view of timing security. Jim Platt is the director of the PNT office for the DHS and previously served as chief of staff for current operations directorate in Department of the Army. So with that, I'd like to pass it on to Barry Dropping. Next slide, please.
Thank you, Mark, and thank you for inviting us to join your session today and sharing this one for us. On the next slide, I'd like to just start with a little bit of a view of the landscape. This represents the output of some study done by the Department of Homeland Security. James Platt will go into that in some more detail later, but I just wanted to use this up front to give a landscape of where GPS is used in timing for critical infrastructure and critical resource sectors here in the US. Many nations are doing similar studies, all coming to the same conclusion that GPS timing is really essential to many of these critical infrastructure segments. The study here concludes that GPS is used in 15 of the 16 sectors and is deemed to be essential in 13 of those sectors. As Mark talked about, many of these sectors are going to focus detail in the WSTS conference. I picked out a couple just to give a little sample on the next slide of of what some of those timing requirements are and the levels of accuracy needed. So I'll start with communications, and the easy statement is all communication systems rely on synchronization to work, and that synchronization comes from GPS. If I look at the fixed communication systems, the regular telephone companies for voice and data services, all those networks require what's known as a primary reference clock. There are standards that dictate what that clock accuracy needs to be, and that accuracy is for frequency is 1 part in 10 to the 11th. So those clocks at the source for all the communication networks need to be very, very accurate. The most common way to do that is to use a GPS receiver in a clock with a very good oscillator, build a system from that. And here in the US, we have thousands and thousands of these clocks on what are known as telecom central offices. So heavily reliable, and a heavy dependency on those clocks for the communication systems. I also added some points here around the wireless networks. Many of the new advanced wireless networks, like the LTE that we all use on our smartphones today, these high-speed data services need that same frequency precision, but they also need time and phase alignment. And the time for the source of those clocks is specified to be 100 nanoseconds, traceable to UTC. And then across the network, to deliver clocks to the end application, the radio base stations, for example, they need to hold 1.5 microseconds. So these are very, very tight levels of precision for communication networks. The next one I'll profile a little bit is the financial sector. This one's interesting because this had to do with regulatory compliance, and the concern here is around high-speed trading. So computer-based trading algorithms that rapidly take advantage of any small discontinuities in pricing of securities, and there are big algorithms behind those of how they operate those high-speed trading. So that gave rise to the need to audit these and increasing levels of accuracy. So the method chosen to do that is to use very tight timing. They need traceability to, as shown here, 100 microseconds to UTC. And this is a evolving requirement that came in last year and has driven a lot of critical thinking on how we're going to time those exchanges. But any exchange or any trading house that is doing work with the European exchange, and of course that applies all over the planet, they have to comply to this, and they need to have this this audit trail in place, and it's compliance against these MiFID II requirements, as they're known. This is a whole track of topic area that we'll go into at the WSTS conference, but it's a very new segment that has very big dependency on timing to UTC. Power grid is an interesting one. Power grid, and Mark, this is an area you have a lot of background in. You shared a paper with me that you published on it, but they have the need for synchrophasers to measure the phase alignment of all the different sources of power coming onto the grid. Alternate power sources coming onto the grid need to be phase aligned. And this has a requirement to phase align to 1 microseconds for these measurements. And again, this is traceable to UTC, 1 microsecond. And the only way to do that in a practical sense is to use a GPS-based receiver to time align. The last one I want to mention is a public safety issue. It's around E911. Now, when you're at home and you pick up your regular telephone service, if you still have that, you make a 911 call that goes into the network, and they know your location. So as long as they have good synchronization on the network and that communication segment works, you'll be able to have first responders know exactly where you are. The challenge, of course, is many people today don't have a regular telephone line at home. They rely solely on their wireless services. So the government has put in requirements for enhanced 911, and the networks need to be able to trace where you are. There are various techniques used. One of the most common one is what's called observed time difference of arrival. Essentially, it's a triangulation technique that says we're going to have these measurement units, and the measurement units need to be very tightly aligned in time. They have a requirement to have coordination of 100 nanoseconds, again, traceable to UTC. They get that from the GPS system, and then they can triangulate and locate where the wireless caller is so that a first responder can be dispatched to the proper location to provide aid. So that's just a sample of a couple of segments, a little bit about why synchronization is important. In all cases, the dependency here is on the GPS system, and you see the very tight levels of synchronization required. On the next slide, I've put a little bit of an example. You hear a lot in the industry now about LTE, advanced services and wireless, and 5G coming on, and this is an area where the requirements are just getting tighter and tighter. This one is just a reference chart. It's kind of an alphabet soup of acronyms here. But what I did is I added a little bit of what's the impact for synchronization. And I would say it falls in two categories. You know, if the system is grossly off synchronization, the system doesn't work at all, and you'll have drop calls. You will be able to not even initiate calls. On some of the advanced high-speed data services, you start to see things like pixelization of your video, things like interference that occur, and spectral inefficiency. So it really starts to degrade the service. So the impairment happens in two ways: degradation of service, and then also complete loss of service. So Mark, that gives a little bit of a landscape and some of the different requirements out there.
Thanks, Barry. Just a quick question. In these LTE impacts on due to synchronization, how many of these are safety issues?
I would say for LTE, it's more about making sure you could initiate a call. I think the biggest thing with your wireless network from public safety is that enhanced 911 capability, and that really has to have tight synchronization, 100 nanoseconds at what are called the LMUs, the location monitoring units, and if those things drift off, they won't be able to locate where the caller is. So the emergency services, they can't be dispatched to the correct place.
I see.
Yeah.
And you said that people generally get UTC from GPS. Are there other ways to get UTC for all these users?
Well, that's a topic of interest in the industry, and segues a little bit to our other panelists here. But people are looking at network-based solutions that I could have an area where I've got a time scale and then use the network to distribute synchronization. That's one that's promising. There are alternate terrestrial solutions being proposed, but it's clear today that the workhorse for this and the method is to utilize the GPS system. Well, thank you, Mark. With that, I'll transition to our next speaker, Kevin Coggins with Booz Allen Hamilton, and he'll also give us a little profile of some of the defense-related use cases for GPS.
Hey, thank you so much, and thanks for the opportunity to address this topic, which is also a very deep passion of mine. In my time leading DoD efforts addressing PNT challenges, I've had a particular focus on understanding vulnerabilities, achieving resiliency, which we called assured PNT, and countering the ever-growing threat. My thinking stretched a lot between short-term solutions and long-term strategies, and that shapes some of what we're going to talk about today. There's very strong parallels to the challenges faced by DoD to the commercial marketplace and critical infrastructure. And today, when I speak of critical infrastructure, I'm including commercial technologies and systems. My goal is to illuminate for you the concepts of vulnerability, threat, and systems understanding, and using this, help you to envision a path forward toward mitigating PNT challenges. So, from a DoD perspective, and I challenge to say from commercial and critical infrastructure, PNT is a critical enabler. In the Department of Defense, it's critical to all of our weapon systems. These weapon systems operate as a system of systems. Few are used in isolation. For example, the radio you see there, you never have a soldier just use a radio. He's speaking to another radio, and there has to be time synchronization in order for that channel to be established and for the encryption algorithms to work and for the bandwidth to transfer the data to be effective enough. And then that data has got to get transmitted potentially to a UAV, maybe an uplink to a satellite, and out of the battle space and sometimes back into the battle space. And some of that data makes it all the way to a missile or munition that has to then fly towards some target. And so if you disrupt PNT just for that radio, you can desynchronize our ability to do our jobs, to have an effect. And that same thing applies to critical infrastructure. PNT is the #1 critical enabler for DoD weapon systems, and within that, the primary means of achieving it is with GPS. And within this, timing is absolutely the most critical. If you recall from the news recently, there was a strike on Syria, and countless systems were involved using even a scenario I just named, to where we had munitions from multiple countries and from multiple directions and multiple platforms launch, and they all hit their targets in a very short time window, you could say, at the same time. Without GPS, without PNT, that would not have been possible. Key point I want you to understand is PNT has been a critical enabler ever since we started warfare. Now, as we transition to critical infrastructure and commercial systems, PNT is also the key enabler for that infrastructure that drives our modern society. There are many things we would not be able to do and technologies we will not be able to advance without PNT. And we have an expectation of technological performance and stability. When we need to communicate, we pick up a phone and it just works. We can travel freely. We flip a light switch and lights come on and they stay on. We can pump gas in our cars and somehow there's always food on the shelf. There's always packages in Walmart. We have very strong expectations as a society that are underpinned by systems enabled by PNT. If you dial 911, we expect someone to come to right where we are. We also have an expectation of continued technological advancement. We want autonomy. We want machine learning and distributed decision systems. These technologies are what many companies are relying on to compete and to differentiate themselves against competitors. Without PNT information enabling those, it's going to be very difficult to achieve. Imagine a self-driving car that can't get from point A to point B or can't communicate any of the data it needs to communicate to maintain its autonomy. PNT information has to be reliably accurate, present, and secure. So a question I have for you to ponder is, what additional margin or competitive edge does having an affordable, resilient PNT capability provide? And what are the risks to your company or your clients if you can't provide capabilities that have PNT resilience underpinning them? Next slide, please. So a critical enabler is a very important thing. The challenge comes when the critical enabler becomes a critical vulnerability. There was a great German military strategist that coined this term center of gravity. If you find that thing that's at the center of your enemy's capability, trace it back, and you can defeat or prevent them from accessing or using that thing. You can defeat the enemy. If it's economic, we go after someone's economy. If it's food production, we stop their food production. If it's their critical infrastructure, you stop their critical infrastructure. And their society collapses. Their ability to wage war collapses. So the center of gravity of our PNT capability is right now GPS. While there are many other means to achieve PNT, GPS is the main one that we use. Advance, please. Let's talk about DoD adoption, and then we're going to talk about commercial adoption. And go ahead and advance through all of these bullets, please. It's ubiquitous across most systems. We put it in everything. We didn't look at it before we put it there. We just assumed it was good. There's no provision for timely updates. Have you ever been delivered a software patch for a GPS receiver that you've purchased? It's very rare. Without an architecture that facilitates ease of upgrade, you have to replace the whole system. So if you've deeply integrated it into a UAS like you see on the right, it's very difficult and very expensive to upgrade. So sometimes you leave it. We're often blind to the details of the signal and the system. Most people think GPS just comes from satellites, but there's a ground control structure behind it. There's a network behind that, a very complicated method of determining time and distributing that time and controlling the satellites. And if you get a glitch in any one of those areas, it can propagate through the system and then all the way into your system. And it's without resilience. If GPS were to stop tomorrow, most systems would stop tomorrow. and they wouldn't have the ability to operate, and it causes severe impact. So a few things about vulnerabilities. A vulnerability is that thing in your system that causes you to have a weakness that you can't tolerate. A typical GPS receiver is not a radio. If there's one thing I can teach you today, it's a special purpose processor with a one-way, unprotected data link into your system. There's a lot of data on the GPS signal, and you're not connected to a hard line like you are in your office building with an Ethernet or a secure Wi-Fi that you control locally. The signal could be coming from anywhere. Someone could be trying to prevent your access to PNT, spoof you, and actually inject data into your system. And that processor, that special purpose processor, is going to process that data and propagate it into your system. Next slide. Some implications for critical infrastructure. We've adopted GPS the same way. It's ubiquitous. We have blind trust. It's a static system. It is without resilience in many cases. Many of our critical capabilities do not have situational awareness, and so they have no knowledge of threats in real time. And when I say situational awareness, I mean just monitor L1, that GPS signal spectrum, and see what else is on there besides things coming from the satellites. And that may drive some decision logic you have in switching to a backup or knowing that you're in an elevated risk posture. And often we incorporate GPS without systems understanding. You know, do you know how GPS works, how your system consumes the data, processes it, and do you know how it propagates data through your system into other people's systems? One of the challenges for critical infrastructure is threat techniques are readily available, and the systems, you're able to buy them off the shelf. Now that software-defined radios like the HackRF1 can be purchased online, you can go to GitHub and download spoofing software. And people can create GPS spoofers to generate their own GPS signal, which means they can change your position, or they can leave your position alone and just change your time. Or they can change each of those slowly, so they're very difficult to detect. Or they could not change your position, not change your time, and instead use the data channel on GPS and push data into your system and maybe have some other effect. The biggest challenge with these threat techniques and systems are they're very inexpensive, and we see college students now under the direction of their professors. We see hacktivists at hacking events, all able now to go in and create all these effects and all these threats off commercially available equipment, and they publish nice papers about it so that information propagates. From a DoD side, that caused us a lot of heartache because that means our adversaries got smarter faster. So the questions are the same. What does your system really need? Do you need GPS, or is there something that is more resilient, more affordable, but less accurate, but good enough? How do you architect your system to affordably enable PNT resilience? Once you buy a GPS receiver, you usually don't want to buy another thing. So how can you architect your system or your PNT device for your clients where that's more affordable? How do you prioritize your actions and allocate limited resources? How do you update older systems? In the Department of Defense, I know we have systems that are 20 years old, and I know those exist in critical infrastructure also. How do you get organizations and people to do what is necessary? Well, first you have to educate them. Next slide, please. So let's talk exploitations and mitigations. And we're just going to talk a few today. So there's three attributes that are important when you talk about PNT. Your access to PNT information that's sufficient for what you need, the integrity or trust you have in that PNT information, and the affordability of the solution. So some sample exploitations to prevent your access, one everyone knows is jamming. You just create some waveform in the spectrum of interest to prevent you from accessing the GPS signal, which is fixed frequency, very low power. It's a very old design, and they usually don't have robust anti-spoofing or other types of capabilities in commercial receivers. So it's very easy to jam. It's low-hanging fruit. The next is spoofing. actually presenting a false signal like we talked about earlier. Another is system attack, maybe attacking the GPS system, maybe some attack towards your GPS receiver through another port. Even a cyber attack could be included in a system attack, because many GPS receivers and critical infrastructure might be networked. And so sample mitigations, improved receivers. There are many modern commercial receivers that have extremely good performance in these areas and have been upgraded to deal with some of these threats. I recommend looking into those. There are many antenna technologies that can help, including something as simple as a static choke ring antenna that just limits your field of view to things that are directly above you. One of the most important things you can do, however, is incorporate system diversity, meaning if you get your primary means through GPS, have a backup means through a system that is completely independent of GPS, such as ELORAN, Iridium STL, maybe a fiber link. It depends on your system needs as to the system you use to get system diversity. Integrity, we talked about that earlier. Improved receivers are one of the #1 things you can do for integrity. Many commercial receivers have incorporated very robust anti-spoofing algorithms. Signal authentication, which is something that's not well incorporated yet, but would be very useful in a GPS or GNSS signal, would also be very useful and help an improved receiver. Situational awareness can help. You can usually detect very easily with the right RF electronics that are not very expensive if a signal is not coming from space, if it's coming from the ground, or if it's got different attributes to it than you would expect from a satellite if somebody was parking nearby and trying to fire a spoofed signal at you. And again, system diversity can help with this also, because then you can compare your solution with another trusted solution. And then affordability is one that we've seen creep up a lot in the DoD circles, and I believe is also creeping up in critical infrastructure. It is very difficult to allocate funds because there are limited resources. But if I can cause you to do that, that means you're not going to spend that money on something else. And so I could cause you to spend money to upgrade your system unnecessarily. And the government is very inefficient at upgrading systems, and so it's a perfect way to cause the government a problem. We call this being on the wrong side of a cost-imposing strategy. And this is where open architecture can come in. You need an architecture that is non-proprietary, that supports the ability to upgrade receivers, supports the ability to add in a new technology that can give you resilience. And finally, in order to mitigate any of these, you really have to understand your system and how it consumes PNT information. Next slide. Okay, thank you so much for your time and allowing me to present. And now I'm going to pass on to my colleague, Mr. Jim Platt from the Department of Homeland Security, and he'll speak to you about threat mitigation.
Hi, good afternoon, everybody. And Kevin, thanks for the nice setup on the topic I hope to discuss here. So if I get the next slide, please. So next slide. We really want to talk about DHS's role in critical infrastructure, how DHS views timing within the critical infrastructure ecosystem, some ways that we look about managing risk. The good news is we don't have to start from the beginning. DHS and FEMA has been managing risk for the nation's infrastructure for quite a long time now, not quite as long as DoD, but we do have some experience here. We don't have to start from the ground. Talk a little bit about the notional PNT architecture that was developed back in 2008 and how that's starting to emerge in some ways, but not in as coordinated way as we would like to have. And then kind of a way ahead for where we think DHS is heading in concert with our community partners. Next slide, please. So I think the most important thing for us to talk about is the fact that a lot of people in the past couple of years have been talking about the security of PNT, and that we have to understand where our signals are coming from. We have to find ways of preventing people from jamming or spoofing us, and how to go after those individuals. And all those things are important to do with critical infrastructure and PNT. But the part that I think that we've not been as successful on is the resiliency side. And so DHS defines resiliency as ability to prepare, adapt to changing conditions, then withstand, and then rapidly recover when something is going to happen. And I think that's a really important standpoint, because everybody should operate on the assumption that eventually something is going to go bad. No matter how well you build your wall, no matter how good your security is, there's going to be a time and a place where those systems, for whatever reason, don't suit your needs, and you have a degradation in your system. So the question becomes then, how are you going to have a degradation? Is it going to be an immediate collapse of your system, or is it going to be a controlled shutdown where you can easily recover and return to your revenue generating operations for which your company is usually there for in the first place? And those are the type of discussions we think we need to have with our clients and owners and operators of the critical infrastructure. Next slide, please. This is just a repeat of, in a little different format, of what we view critical infrastructure within DHS. And the most important thing here is that this is not something that the government is going to solve for people. This is going to have to be a coordinated effort. But we believe that, go to the next slide, please. The one thing that is common across all of critical infrastructure is there's this underpinning of time. It seems that everybody now is moving to more and more precise timing so that we can squeeze more information, or squeeze more efficiency of the spectrum. We can become more efficient on the electric grid. There's just a whole host of reasons why, when you have precision time, you can make things more proficient. So we've been moving towards that for year after year. Back in 1998, President Clinton commissioned a study on whether or not our infrastructure was becoming too dependent on technology. One of the findings of that study was that we are moving towards that every year. We're getting more and more dependent on information technology. But they also highlighted, even back in 1998, that we were becoming more and more dependent on GPS for time. And that resulted in the nation eventually coming out with National Security Presidential Directive 39, which is space-based PNT, that told us we needed to build the backup capabilities. That was in 2004. And there have been many studies that have proven it out, that we continue to become more and more embedded and more reliant on GPS for position, navigation, and timing. And that's a trend that we want to, within DHS, we want to really take a look at and decide how we can, when it is appropriate, how we can walk back that dependence that we currently have on GPS. You heard from some of the previous briefers that certain things are dependent on UTC. We go back to them and ask them, are you really dependent on UTC? Could you operate if you weren't dependent on UTC? Are you really using the GPS signal for synchronization rather than for timing? And if that's the case, are there other ways of keeping your network, your system synchronized? But if you are dependent on UTC, you got to have to start asking the questions. How do you get UTC? Was it by default that you decided to use GPS or some other GNSS system? And do you understand the vulnerabilities that come with those systems? And if we don't ask those questions, that's when we start finding ourselves getting into trouble with systems that suddenly collapse, and we ask ourselves after the event, well, why did that happen? I didn't know that was going to happen. So we should be asking ourselves too, how do we operate without GPS, and how do we operate without traceability back to UTC? When we start asking those questions, that's the first step in us to building some resiliency into our systems. Next slide, please. So how does DHS look at this from a holistic standpoint? It's got to be an integrated approach, and we have to start thinking about systems and how we're managing risk. And it's not just risk to PNT, it's risk to our systems. I would have ventured to say, if many people went in their boss and said, boss, we lost timing, that wouldn't cause a lot of concern in the C-suite. When they went in and said we lost timing enough where the networks are down, or we can no longer potentially use the air carters within the national airspace in the manner that we're using them, that's when we start seeing people starting to get excited. So we have to change the discussion a little bit. It's not about losing time, it's about losing critical capabilities when you lose time. To reiterate what Kevin said, absolutely. I think everybody has to start taking the idea that when you hook up a GPS antenna to your receiver, or to your network. You know, for all practical purposes, it's not quite as quick, but you might as well potentially hook a keyboard into that as well, because you have a inject now into your system, and if you understand that, then you can start applying some of the cyber hygiene things that most of us are getting better at into our PNT systems. We've always got to look at new technologies, and then we have to keep our national policies relevant. The national policy we have now is 2004. We need to take a look at that. A lot of things have happened since 2004, especially with the advent of the cyber threats and some of the other threats Kevin mentioned, that we need to make sure that we can respond as a nation appropriately when there are threats and emerging issues. The next slide, please. So, as I said, none of us can do this on our own. This really has to be a collaborative environment, and this is how DHS envisions the collaborative environment in the National Infrastructure Protection Plan from 2013. We have the owners and operators out there, and many of them will want to do the right thing, and they have individuals within their organization who are trying to do the right thing. There may be a knowledge gap at some points where NGOs, state and local officials, the federal government may be able to help them with the knowledge gaps that they have. Or in many cases, the owners and operators can come back to the federal governments and highlight the vulnerabilities that they've identified and the assistance that they need either from the federal government for local entities. So it's a two-way street so that we can bring the appropriate resources to bear. We can identify who the experts are in the industry. And we have this collective effort to not just assure resilient timing, but to ensure the overall effectiveness of our critical infrastructure. That's ultimately what this is about. Because as was mentioned earlier, it is very possible that communications could be disrupted if we lost GPS. Emergency responders can't respond. So those sectors that we view as lifeline sectors within DHS, which have to be restored first so the other sectors work, are heavily dependent on timing. And it's absolutely essential that we have a working, cohesive group to get after this problem as we move forward. Next slide. So the National Infrastructure Protection Plan talks about mitigating consequences. And I think this is really important to take a look at this. And this is pulled directly out of the Infrastructure Protection Plan. Where we really need to look at the resilient piece is taking a look at consequences. Many times people will talk about risk or vulnerabilities and equate those to consequences. When we identify where those areas that would actually cause harm to the nation or cause a significant disruption to our economy or will disrupt the way of our citizens, that's when we have significant consequences. And those are the areas where we have to ensure that we have security and resiliency within the infrastructure. If a system is solely dependent on GPS and that system were to go down because of the loss of GPS, that does not build trust and confidence in the American people and the federal government or the industries that are operating them, because in the after action reviews, it usually comes out that, yes, we knew these vulnerabilities existed and they weren't properly addressed. So it's important that we understand where we operate in the National Protection Plan mitigation sequence, and that we do this as a community, not simply as individuals looking at our slice of the pie. When we can have redundancies, that's a great system, as long as it is well thought out in the redundancies, so that you understand that if I lose time and I go back to another timing source that maybe isn't as accurate, I have a degraded effectiveness. But everybody knows that degraded effectiveness is taking place, and therefore there are mitigations in your tactics and operational procedures to effectively continue the critical service that needs to be conducted. When possible, sometimes you want to try to disconnect those critical services. Do you disconnect from GPS, or you disconnect from the network? There's a particular instance I was recently made aware of, where a sensor that was feeding information back to an operations center was getting data in. They were passing it back over fiber to an operations center, and yet they had a GPS antenna on that particular receiver to gather timing, when the timing off the internet would have probably been just as accurate. So we just introduced a a vulnerability for absolutely no reason other than the fact GPS was available to them. So as you look to find these things, you have to replace and repair infrastructure. It shouldn't just go by the same thing we bought last time. We should take a look at the vulnerabilities of those systems, replace those things on their life cycles, and that way you reduce the cost of upgrading, but you're making smart upgrades for the future. And ultimately, this is really about information sharing, so that when vulnerabilities are identified, we can get that out to the community, and we can work collaboratively to get to the resolution and build resiliency into the system. And I want to keep harping on the resiliency fact, because I don't care how high you build the dike walls, I don't care how good your security is, something always happens that makes those defensive measures not work. What we have to understand is we have to be able to continue operations regardless of those defensive measures failing. And once we do that, we are meeting our obligations to the citizens of this great country. Next slide, please. So, so we didn't have to start from scratch. FEMA's already developed a national mitigation framework, and we really should be looking at prevention and protection. So if we can prevent these things from happening, that's really good. But we have to take a look at the mitigation efforts that are taking place. And a lot of times these are less energetic, because it's kind of tough to sell your boss on, well, we need to mitigate the loss on GPS. And the question comes in, well, when's the last time GPS failed? Well, that's really not the question to ask. The question to ask is, what are the consequences if GPS fails? And then mitigate against those consequences. How do we respond and recover? And understand that we're recovering as part of an ecosystem. We're not in isolated communities. We need to understand that. And then we really need to start changing, and Kevin alluded to this a little bit, we really need to start changing our thought process about the future. We don't need to be bolting on mitigation efforts after systems have already been deployed. Now, there are going to come times where you're going to have to put out patches, you're going to have to modify systems once they're deployed. But we have found within DHS that is, if you start planning for mitigation in the design phase, many times you can build significant resiliency into the system at a very low cost if you're addressing this within the design phase. So if you have a design phase and we're looking at alternate PNT systems, and you can receive timing over fiber, you can get timing over GPS, you can get timing from other satellite systems, you can get timing for WWVB because you only need, millisecond level timing. You can pick which ones of those systems to use, or maybe pick those as one as a primary, other as fallback, and another as a tertiary system. There are ways to build those things in early on so that we don't have to rely on trying to replace systems in a crisis. Next slide, please. So, and this is what I was talking about. So back in 2008, the Department of Defense, Department of Transportation put together a national PNT architecture. And you can find this within the 2017 Federal Radio Navigation Plan. It's out there for public use. You can take a look at these things. This is what was envisioned as being the ultimate solution for resilient PNT. We'd have multiple phenomenologies so that you can pick the phenomenology that is best for your solution set or your business model. And a lot of those phenomenologies are coming online. Some of those are pay for services. We have timing over fiber that some of the financial industries are using. We have other industries pursuing timing systems through other commercial companies, which I can't specify which companies they are, but there are companies out there that are delivering timing capabilities. So you can decide what is most appropriate for your company. And if you're going to pitch to a client, you can pitch that any one of these systems is not what you should be looking at. There are other solutions other than GPS out there, and we should assess whether or not they fit into our business model. Now, the federal government, we are assessing, this one of the highlights is we are assessing the possibility of fielding alternate and backup PNT capabilities. That has been a requirement on the books since 2004. DHS has recently completed a timing validation study, which you saw earlier in the brief, and we just finished a position and navigation study as well, which we hope to be validating both of those requirements and then releasing to the public. But the long and short of it is the telecommunications industry is probably the most reliant on precision timing. And in position navigation, we're finding out that a lot of the areas that critical infrastructure depends are actually using augmented systems. So they're not using GPS directly, they're using RTK systems, which really makes it difficult to back up because there's an entire infrastructure that is built around augmenting the GPS signal and providing a very precise, sometimes down to the 4 centimeter level, PNN solutions. So ultimately what we ask is, do you have a strategy for identifying your timing needs, and have you selected the appropriate timing source? So you say, how do we get there? We are currently working through the Enduring Security Framework, which is a partnership between Department of Homeland Security and the National Security Agency, to work with industry to develop a template for companies to go in, assess where they're actually getting their time from, and then develop a strategy for identifying the most appropriate time source. Now, this may sound like a simple solution, but I will tell you the company who will remain nameless, but a very large company, very tech savvy, went back and did a timing assessment, and they weren't willing to share the results just yet, but they did find numerous issues with where they were getting their time and how they were managing their time, and they've taken a major effort to revise those. So we look forward to them sharing that information eventually and putting out some best practices to you. Next slide. So don't want to belabor this. I want to leave a few minutes for questions, but DHS is going to validate the critical infrastructure timing requirements in the very near future and go back to Congress with that report to see where we're going to head as a country for backup and alternate capabilities, to find out how we actually meet the requirements that were laid out in NSPD 39. We want to develop a competent PNT framework so that if you are getting multiple solutions from PNT solutions and timing solutions, there is a competent framework to help you work through which solution sets you're going to use. You know, there's a saying, if you have 1 clock, you know what time it is. If you have 2 clocks, you're never sure. Well, if you have 5 clocks and timing in sources, it gets even more complicated. We want to normalize the PNT risk management decisions. This should just be part of the business decisions that you make every day and your risk management decisions. And ultimately, we want the result to be secure and resilient infrastructure, not just secure and resilient time. So with that, thank you so much for giving me the opportunity to speak today. And I'll turn it back over to Mark, who's going to moderate any questions. Thank you very much.
Thanks, Jim. And I'd like to thank the other speakers. We had time for a couple of questions, and you know, just a quick review of what we just heard. We heard about some of the requirements. We heard about some of the threats and some of the need to get better resilience, and then finally some of the ways of moving forward. And I have a question that I would ask of Jim Platt. Jim, how can we test for resilience? How can we know to what extent a system is resilient? How do we develop test plans? And if there are threats that are classified, how can we test for them?
Well, Mark, that's a really good question, because testing always involves a little bit of risk too, especially if you don't have a test bed to check your equipment. But you know, as we do our continuity of business operations, there are times that we fail over certain servers to other servers to make sure that we can continue operations there. During scheduled downtimes and scheduled maintenance, has someone decided to, for instance, disconnect the GPS antenna in a controlled environment and determine whether or not the oscillators that was actually running the system, does it continue to operate in the manner that you expect it to? So you have to design those test plans to do some real life applications. And I think you're aware of the incident out in the ION conference in Portland, where a GPS emitter was emitting into the hall, and a cell phone picked that up, and the cell phone basically became a brick. So the question is, you know, it would be very possible to do that test in a lab or do that test in a R&D within a company, but people didn't think to do it. So I think that's the big thing. You just have to take the time, develop a test plan, and very carefully, so you don't interrupt your business operations, attempt to see how your system operates if the PNT system is or the timing system is disrupted.
Thanks, Jim. Here's another question we got from a viewer, and I think this is also for Jim. What is the status of DHS finishing its requirements assessments, which were required to be published last December under the 2017 NDAA, and when will they be made public? Jim, can you respond to that, please?
Sure, Mark. Thanks for the question. So it is true the NDAA, National Defense Authorization, came out last year and tasked agencies, both DOT, Department of Transportation, Homeland Security, and Defense, to validate the position, navigation, and timing requirements. Unfortunately, we're not going to make excuses, but due to continuing resolutions and other things, we've kicked those things off now. As I mentioned in the briefing, we have completed the timing study. We're going through a review process to release that information to the public. And just within the last 2 weeks, we completed the position and navigation study. So we're going through the final review and acceptance from the contractor, and we intend to do the same thing on the timelines to release that to the public to make that information available. And of course, that will feed into an analysis of alternatives that we're doing. And there was a request for information put out on the Federal Register, which I am happy to say there was 18 different submissions from different individuals and companies on potential position navigation and timing solutions that could provide backup capabilities to GPS. Our goal is to finish that by the end of this fiscal year, do the interagency coordination, and then respond back to Congress so that can inform national decisions. Thanks.
Great, thank you. So I have a question I'd like to, I think this is going to have to be our last question just because of time here. But Kevin, I wonder if you could address this. So some commercial solutions are claimed to be available for assured and resilient PNT. How do we evaluate and review these, and how can manufacturers present their solutions, how and where? Do you have some ideas on how to move forward with this?
Yeah, certainly. So Mark, did you ask me if I've evaluated these commercial solutions on assured PNT?
No, it's more about in the industry, how can this be done in a general way for all users or for a general user?
Well, you have to start with your system requirements, and because one solution may be resilient for one set of system requirements, but not for another. It matters what kind of data you need. Do you need timing? Do you need position? And to what accuracy? So, you have to start understanding your system requirements. Then, to assess these products, you have to put them through the right tests. And the challenge with that is that DoD and the government, they're not going to release every threat scenario that's possible that could impact some of these receivers. And so you have to figure out how do you tap into that knowledge base, or how do you get guidance on how to test these receivers on these complex threats that could happen. So my recommendation is start with understanding your system and the level of resiliency you need and can afford, and start to assess this solution from there. But you're also going to have to find a trusted agent or build the capacity yourself to test this device and test your system using this device through many scenarios to prove out the resilience.
Great. Thank you very much, Kevin.
Mark, this is Jim. Could I just comment on that, please? And that's a really important point, because you're going to have to test your systems, not just your PNT, because there's a whole reason a bunch of PNT receivers could fail. There could be a bug in the system. There could be a power surge that fries your system. So the key is making sure that your system is resilient, not just your PNT system. So even though you can't test against every conceivable bug, it is good to know that your system can continue to operate should there be a disruption to PNT.
Spot on, Jim. Great.
Good point, Jim. And I think on that note, we'll have to end the questions here. And if you would go to the next slide, I'll bring the webinar to a conclusion, next couple of slides, but we'll start with this one. Again, I want to remind you all of the workshop on synchronization and timing systems happening June 18 to 21 in San Jose. Register soon. The hotel availability is coming to an end. And if you go to the next slide, I would say that immediately following WSTS, the date on this slide is wrong. It should be, I think, the day after the end of WSTS, which I think is June 22nd. But there's going to be a workshop on assured access to accurate time, co-located with WSTS, and immediately following it, WSTS is on a tutorials on a Monday, then Tuesday, Wednesday, Thursday, followed by this workshop on a Friday. So a good week to learn a lot more about timing and resilience. And so I think with that, I want to thank everyone for attending this workshop. I think it was very well done. I really appreciate all the speakers, appreciate ADAS for hosting it, and all, as you see, all registered attendees will receive a follow-up email containing links to a recording and the slides from this presentation. Thank you all, and I will conclude here.